Hello, today we'll be going over intermediate value theorem for calculus, also known as IVT. Okay, so before we start, we need to go over continuity. So continuity at a point means four things or three things, because these this third one means the second one has to be true. So three things are: at that value, there needs to be a functional value, meaning at that point, the x value, there also has to be a y value. If you're doing calculus, you know what limits are. You need to have a left and right limit at that point. And then the functional value needs to match the overall limit. So left and right limits need to match for this. So here's an example. We have 2 times x squared. You see here that this, from the range that we can see, it is continuous at all points. If you pick any point, there's a value there, and there's also the limit of each side also matches, which also matches the functional value. Now let's say at x equals 2 is over here. If we were to say at x equals 2, it's not going to equal 8, it's going to equal 3. Then it's not going to be continuous, because you have a hole here, which is then replaced by something over here. The limit might exist up here, but the limit does not equal the functional value. Here's an example of not continuous at all points. This one may look rather obvious to a lot of you, because you can just see a large gap between approaching from one side and approaching from the other. This is x over x plus 1. So this is not a polynomial. Just take it in. So this is continuous, this is not continuous. And here it's specifically not continuous at x equals 1. At x equals -1. However, if you were to take it within a range, let's say we were doing from 5 to 10, so that's this small line over here, then yes, it would be continuous at all points within the interval, because there's no large jumps or anything like this. IVT only works when all points in the interval are continuous, so that's what's shown here. So if we were to go from infinity to -1, then yes, it would work. But if you were to go from -infinity to 0, it wouldn't, because you're passing through -1, and we know it's not continuous there. IVT states that if a function is continuous on the closed interval a to b, so let's use this as an example. So a to b, 0 to 2, and if L is any number between f of a and f of b, you don't need to know L, but it's just saying that this number exists, then there must be some value x equals c, where c is between a and b, and that f of c equals L. So what are we trying to do with this? Let's do x to the power 2. Let's create a range 0 to 4. Okay, now if we zoom out, okay, there we go. So what this is saying is, if we pick any point, if we have the function x squared, and we have given an interval 0 to 4, and we want to find out if we have a value, I have an x value that will make the function equal 8, then by IVT we can guarantee that there's always going to be 1 point available, because the function is continuous. So x squared, why did I delete that? Let's start at 0, we go up to 4. So what we need to do is find the functional values of each. So 0 squared is 0, 4 squared is 16, 4 squared is 16, there we go. I accidentally did 4 to the 16. Okay, so 4 squared is 16. That means because the function is continuous along this. Let me pull it up again. Along the interval 0 to 4. And let's say we're looking for a value where y equals 6. By IVT, we are guaranteed a value because the function is continuous, meaning it never breaks. There has to be some way for it to cross this line of y equals 6. And one place where we like to use this is when we're solving for zeros. So let's do x cubed minus 6x plus 5. Oh, that's not a clean one. There we go. This looks better. So we know that there's one 0 at x equals 2. Okay. But we also want to figure out where the other zeros are. And we know that we can have up to 3 zeros. So one thing we can do is start taking values. Okay. 3, 4, 5, and so on. And we can also do -3, -4, -5. Okay, so you look at all these points. How about we zoom this out? So let's ignore the graph. We'll come back to it later. But if you look at all these points, you notice at -1 to 1, it flips from 9 to -1. So we use IVT for this example. All polynomials are continuous, so it will work in this interval -1 to 1, shown down here. Now, if we want to we have to find the functional values. We know those as well, 9 and -1. Because 0 is between 9 and -1, it works for IVT. And now we can say that there has to be some value c in between -1 and 1 that ensures that there's a 0 there. So if we look at here, -1, 9, and as we travel along the graph, we notice we cross 0. This graph, it's 0.732, and then we get to 1, -1. Because the function is continuous, it can never just skip 0. So as long as it goes from one part to another, it has to cross all the points in between. So let's do an example. Is there a value c on the interval 1, 11 for the function f of x equals 2 times x to the power 3 minus 5x plus 6, where f of x equals 4? Okay, let's do this over here. The graph will be on the side, but we're not supposed to use it. We have 2x squared minus 5x plus 6. Go. We're looking for a part where y equals 4 along the range 1 to 11. Let me move this up here. Okay. So, now what we have to do is take the functional values. Let's take it at x equals 1. So 2 minus 5 plus 6. That equals 3. Let's take it for 11. 2,602 minus 55 plus 6. Okay, so we get a very large number for that part. But if you noticed, 4 is in between 3 and 2,613. Therefore, this works for IVT. The answer is yes. There is at least one value c. You can't figure out all the values, but you know there's at least one value c on the interval 1 to 11, closed interval, where f of x equals 4. Now we go to the graph. Let's make this so you can see it. Our values are here and here. However, we can only know about one of them because first of all, only one's in our range. And if we were to make our range larger, we could only guarantee there is at least one of them because it doesn't account for all of these twists and bends in the function. Okay, let's do another one. Now our interval is 4 to 10. 4 to 10. Our function is 1 for x plus 6. And we want to find out where y equals 1/12. So now we go through this again. We find, first of all, you need to figure out if it's continuous. You can quickly just figure that out by finding where x plus 6 equals 0. X will have to equal -6 because that's not within our range. And we know that there's only one spot where it should be discontinuous. The interval, we can use this interval for this problem. So now we can just start off by doing taking functional values. 1/10 for x equals 4, and 1/16 for x equals 10. So finally, we can tell that 1/12 is in between 1/10 and 1/16. So that means this problem does work. We have a point, and if we look at the graph, at x equals 6, we indeed reach 1/12. So finally, we got this one. This is just the same thing as before, except our range has changed. So now we're going from -20 to 10. And we're still with the same function and the same part to look for. Now we reach a problem, because now it's not continuous along the whole graph. Because, as we saw before, the one part where it's discontinuous is x equals -6. That is now within the range of -20 and 10. Therefore, you cannot use IVT to prove this. And as you see here, there you go, Control Shift. Let's do Control Z. Right here, at x equals -6, we have that large jump from -infinity to infinity, and that's why this does not work. Okay, so I hope you understand how intermediate value theorem works. First, you need to know what continuity is, where the left and right, the limits need to match the functional value, and both of those must exist for the point. Here are some examples of continuous and non-continuous. IVT only works when all points in the interval are continuous. IVT states that if a function is continuous on this interval, and L is a number between a and b, f of a and f of b, meaning the y value, there has to be an x value where f of c equals L, where c is between a and b. And we went through 3 examples and showed that for these first 2 it does work, because our function is continuous along the interval, and then for each of these there is a value that exists. And finally, for this one, there is no, you cannot prove it because -20, 10, our interval, crosses the point where this function is discontinuous, x equals -6. Okay, I hope you enjoyed. Send this to anyone if they need help with intermediate value theorem. Check out the YouTube channel for other problems. Like and subscribe, and I'll see you soon. Bye.